Okay, so we can see three logic gates on the screen. So these are the logic gates in digital electronics. So the first one is called AND gate, and the second one, this one is called OR gate, and this one is called NOT gate. So first come to the AND gate. So for AND gate, if you apply A and B in the input terminal, then at the output terminal you will get A dot B. Next come to the OR gate. So for OR gate, if you apply A and B as input, you will get A plus B at the output terminal. Similarly for NOT gate, if you apply A, you will get the complement version of your output, which is A bar. Now come to the construction of the truth table of these three gates. So before the construction of the table, you must remember that in Boolean algebra, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. Similarly, 0 dot 0 is 0, 1 dot 0 is 0, and 1 dot 1 is 1. And one more thing, that 0 complement of 0 is 1 and complement of 1 is 0. Now come to the construction of the truth table for AND gate. So you can see for AND gate there are two inputs, A and B. So A and B are the two inputs, and the output we are getting Y as our output. So as you can see, two variables are there. So 0 0, 0 1, 1 0, 1 1. So for AND gate, based on this logic, so for 0 0 we will be getting 0, for 0 1 we will getting 0 again, for 1 0 0, only for 1 1 we will getting 1. So this table is constructed based on this logic. So you must remember this logic. Next come to next gate, which is our OR gate. So for the OR gate, input are two variables, A and B. You can see A and B. So at the output we are getting A plus B. Okay. So for OR gate, we will be getting 0 plus 0, which is 0, 0 plus 1, which is 1, 1 plus 0, which is 1 again, and 1 plus 1, which is 1. So this is the truth table of OR gate. Next, come to the truth table of a NOT gate. So you can see for NOT gate, there are only one input. Okay, so it's a one variable, which is A for input, and Y, which is A complement. So as you can see, there is only one variable or one input. So we are writing like 0 and 1. So for 0 you will be getting 1, and for 1 we will be getting 0. So basically here we are getting the complement version of the input terminals. So this is the logic truth table of the logic gate called NOT gate.